Hello, my name is Kiran Joni. This is the 8th in the introduction series of the Eso-Loop Framework. In this session, I'll be introducing the third component of the Eso-Loop Framework, that is the idea of constraints and constraints-based dynamic design. Until now, I completed introducing the worldview, that is a first key component. A complex ecological worldview was introduced. The second key component is the primary keystone constraint, that is effectual self-organization. In this session, I'll be introducing the third key component and the final component, that is the idea of constraints and constraints-based dynamic design. I'll be using Alicia Herrero's idea of context-sensitive and context-free constraints as a frame to facilitate this introduction. So let us start with the idea of constraints itself. Constraints in this framework is not used in a negative sense of limiting something, but as a scientific foundation, a natural science foundation. This was discussed and talked about and widely accepted by scholarly community. According to Stuart Kaufman, astonishingly simple rules or constraints suffice to ensure that unexpected and profound dynamical order emerges spontaneously. So he places this concept central when it comes to thinking about the dynamics that emerges spontaneously in nature. So this means that the word constraints has a special meaning in science. Constraints are an integral part of life form and self-organization. This is true whether it is the case of genetics as a constraint or mother's womb as an enabling constraint for fetus development, or human morphology and skeletal system. All of these are examples of constraints or enabling constraints. According to Stephen Guerin and Daniel Kunkel, scientific theories that claim to resolve fundamental issues of organization seek to explain the emergence of organization as an expected consequence of driving constraints, forcing systems far from thermodynamic equilibrium. Here, scholars Stephen Guerin and Daniel Kunkel points to several fundamental theories, natural science theories, to suggest that all of these theories confirms to the fact that constraints, driving constraints are forcing systems far from thermodynamic equilibrium. So this is the central and foundational role of constraints when it comes to natural science. According to Alicia Herrero, constraints not only reduce the number of alternatives, they simultaneously create new possibilities. For example, a chair is a constraint. Okay, infinite number of possibilities are taken away to design chair. Chair has a specific shape that enables sitting. Okay, it enables the affordance of sitting. So it is a constraint that enables the possibility of affordance. It simultaneously creates possibilities. When we constrain something, simultaneously it creates possibilities. Alicia Herrero further points to information theory and suggests that constraining the number of ways in which various parts of a system can be arranged reduces randomness by altering the equiprobable distribution of signals, thereby enabling potential information to become actual information. It works by modifying either a system's phase space or probability distribution of events and movements within that space. Constraints thus create coherence. What she could mean is any kind of information transferring devices like language. When we look into the language system, because I'm conforming to the constraints of English language, I am conforming to the grammatical structures of English language, vocabulary structures of English language, the articulation structures of English language. All of these are constraints, by the way. Because of all these reasons, I'm able to communicate certain things to you. So that is exact same thing which Alicia Herrero is talking about here. Because of these constraints, coherence is created. I'm communicating to some extent coherently to you. So that is the point. So let us have a look into some other examples. We already looked into the example of a chair. Another example is traffic system, where possibilities are created by constraining the system by introducing traffic rules, traffic signals, etc. By introducing these constraints, even though it is a constraint, it enables the possibility of large number of people coming together and coordinating with each other to do things and not to do things. So the possibility is created by constraining the system. Money is another example. It is a regulated system in most of the countries and markets. Some institutions, some governments have a role in regulating this, or this is the value of this particular piece of paper. That constraint enables infinite possibilities, enables large-scale cooperation in society. And the fourth key example is the example of language, which I already discussed. The fifth key example is the example of internet, the protocol languages in internet like IP, HTTP. So all these protocol languages enables infinite possibilities. All of these enabling constraints enables infinite possibilities and interaction that happens online. So that possibility cannot be attained without coordinating constraints. Another key example is creativity. There exists a large amount of literature that points to the fact that creativity cannot happen without constraints. In fact, in a very widely read book, The Innovator's DNA, which was co-authored by Clayton Christensen, the author talks about this very clearly. That is, creativity thrives when constrained. So this idea is widely accepted among scholarly community that focus on creativity. Now, when we look into these examples, we might think that these are the only places this is applicable, but that is not the case. Wherever human life exists, whatever kind of systems we look, all of these systems have the foundational dynamics of constraints. Now, as already discussed, I never explained the reason why I'm using the term primary constraint to address effectual self-organization. This is because I thought about explaining this idea when I was discussing the larger theme of constraints in the third component of the framework. That is what I'm doing now. It's important to understand effectual self-organization as a primary constraint itself. So it is a primary constraint that is much more fundamental than other kinds of constraints. So that is an important point to understand here. When comparing all these listed examples like chair, language, internet, money, creativity, traffic rules, etc., the primary constraint of this framework, that is effectual self-organization, is much more flexible and general. This is because it is based on fundamental ideas of natural science like dispositional propensity, adjacent possible, coevolutionary dynamics, emergence, and change in a system. That forms the primary keystone constraints. Now, when we look into the applied complexity models, the language of constraints is explicitly used mainly in two prominent approaches. One is the constraints-led approach in sports coaching, and another one is Dave Snowden's Canevin framework. The constraints-led approach in sports coaching uses the theoretical foundation of Carl Newell's triangle of constraints to define its constraints typology. Based on this foundation, this approach designs and introduces various constraints to the athletes to enable the athletes to explore the stage space to find their own solutions through the process of self-organization. The key idea used here is that by introducing constraints, learners can be guided to seek and utilize the affordances at different parts of the landscape depending on their current needs. Through these interacting constraints, the learners will self-organize to find various emergent solutions by themselves. Now, when it comes to Dave Snowden's Canevin framework, the language of constraints is foundational here also. The type and or level of constraints is used as a foundation to differentiate between four key systems in this framework. The obvious or simple domains are based on rigid constraints. Complicated domains are based on governing constraints. Complex systems are based on enabling constraints, and chaotic systems are based on lack of constraints. A simple system example might be switching a light on and off. A complicated system example might be a car or a computer. A complex system example might be a football game or a forest ecosystem. Finally, a chaotic system example might be a bomb blast or maybe a pandemic situation or something unexpected happening or an accident where people don't know what to do, how to do. So there is no best practices. Nobody knows what to do in this kind of situation. These domains can be plotted also in a linear manner where ordered system and chaotic system are in the extremes and complex systems are in the middle. It is also important to understand that self-organization can only happen in systems with enabling constraints as default constraints. This kind of middle zone constraints facilitate metastability. And this is the only kind of system that can facilitate metastability. That is the ability to accommodate different states happening together. Metastability means all these states can coexist. Apparently, opposing tendencies coexist in the same time in this kind of metastable system. And this can only happen in an enabling constrained middle zone system. According to Scott Kelso, when you go into the metastable regime, you see that you actually have a bunch of complementary pairs, individual and collective, parts and wholes, segregation and integration, choice and chance, competition and cooperation, linear and non-linear, symmetry and broken symmetry, stability and instability, states and tendencies. These are actually complementary. And this exposes basic truth of the matter. That is, when you are in the metastable regime of the dynamics, which is ubiquitous, you see these aspects not as contraries at all, but as complementary. So this expresses a basic truth that both complementary aspects and their dynamics are required for understanding. But one without the other, the understanding is incomplete. So this is a wonderful quote by Scott Kelso pointing to the dynamical aspects of metastability. Now, it is important to also understand that metastable dynamics cannot happen in systems with default ordered constraints, like, for example, a business plan or linear instruction to build a toy or lean startup. It cannot also happen in chaotic systems in which the system lacks adequate level of constraints or have no constraints. Without some level of constraints, there can be no coherence in a system that makes possible to hold on to the system. The system will disintegrate. It is important to understand that metastability can happen only in systems with default middle zone enabling constraints. That is, there should be constraints, but that constraints shouldn't be rigid, but flexible enough to accommodate complex dynamics of metastability, in which the system can switch back and forth to and from other states. This is also important for self-organization to sustain. It is also important to understand that life and self-organization can only sustain in systems that are by default middle zone, that is, enabling constraint systems. This is why we need to design enabling constraints as default constraints, or design such constraints as dispositionalities of the framework itself. That is exactly what I did in this framework. To implement this idea of constraints to the framework, I use Alicia Herrero's conception of context-sensitive and context-free constraints as a foundational frame over which various constraints are introduced. So let us have a deep look into the two types of constraints that was introduced by Alicia Herrero, borrowing it from information theory. So let us start with the idea of context-free constraints. A context-free constraint is something which biases the system even before the contextual factors comes into picture. The context-free constraints takes the system's components far from equiprobability. It reduces the randomness of a system. That means that anything and everything cannot happen. It positively biases the probability of something happening and at the same time reduces the probability of something else happening. So next one is the context-sensitive constraints. A context-sensitive constraint is something that is conditional on the state of the context. In entrepreneurship, it can be entrepreneurial actions and the dynamics of and between team members, partners, mentors, end-user preference, technology penetrations, government policy, infrastructure, etc. Context-sensitive constraints synchronize and correlate previously independent parts into a systemic whole. When organized into a complex integral whole, parts become correlated as a function of context-dependent constraints imposed on them by newly organized system in which they are now embedded. Let us have a look into some of the examples. Take the example of a baby. The baby's genetics can be seen as context-free constraint because it comes before the context comes into being, before the real context comes into being. It is already pre-packaged. It cannot be changed. It is coming before the context. But the interaction of the baby with teachers, parents, peers, food, dolls, etc. can be seen as context-sensitive constraints. But it is also important to understand the context. So every specific context might have different kinds of constraints. We can talk about baby's nutrition and food. We can talk about social development of the baby's language acquisition. All of these are different questions. And if we ask specific questions, we will be getting different kinds of context-sensitive constraints related to that particular question. So there is infinite possibilities that is happening there. When it comes to another example, the crop has a genetical foundation and also the typology is there, what kind of crop it will be. So that is the context-free constraints because it comes before the context comes into being. It is pre-packaged in the system. What will happen in the context is decided by an infinity of things. A particular seed can be eaten by a bird, and maybe the bird can drop it somewhere in a fertile land, and there it can develop into something beautiful. So anything can happen there. The context sensitive constraints depends upon the context. So let us have a look into some other examples. Let's have a look into the traffic rules, traffic of a particular nation. The traffic rules of a particular area or government or a particular local government is decided beforehand. So whether it is India, UK, or America, the rules that are specific to that particular area is decided a priori. It is known a priori beforehand. You cannot change that. It is context free. It comes before the context. But when you are driving, you are adjusting, adapting, not bumping into each other. You're always trying to change your direction, adapting to various adaptive pressures in that particular context. A car will be coming from your left, some car will be coming from the right. An aggressive truck driver is trying to push you forward, trying to put you into pressure. So all of these things are happening in the real context. All of these can be seen as context sensitive constraints. In the internet protocol languages, HTTP, TLS, DNS, TCP, IP, all of these are context-free constraints that comes before the context of the internet. But what you type in the structural limitations of Twitter or maybe Facebook, the possibilities that are available for you in Facebook or Instagram, all of these context-sensitive constraints are very important also. Another example is money. A particular monetary system is a kind of context-free constraint that values certain things and doesn't value certain things. So by confirming with these rules, we can do infinite things in a particular country or place. And these possibilities are context-sensitive constraints. Now, I used the example of constraints-led approach many times to suggest that this particular approach is what inspired me for the design of Eso-Loop Framework. So when it comes to the constraints-led approach, the coaches will use various manipulations, task manipulations. Various kinds of constraints are designed and introduced to the coaching environment by the coaches. But the task manipulations or task constraints can be equipment sizes. For example, smaller size bat or smaller size ball. The space density manipulation, like reducing the size of the field in which the play is taking place. The time, reducing the time, instruction, different types of instructions are given. All of these are constraints that will be introduced to the game situation to enable the athletes to explore the state space, to find their own solutions through the process of self-organization. This is the idea which I talked about earlier on. So this planning and implementation is context-free. No matter what kind of plan, if it is a plan or design, it comes before the context. But what happens in the field while the player is engaging in the real world context, that is context sensitive. The self-organization happens there, and self-organized solution finding happens as a context-sensitive constraint that coherently brings together all these context-sensitive and context-free constraints together in the real world. So in order to implement this idea, let us have a look into the domain of entrepreneurship using the frame of these two types of constraints. It is important here to understand that entrepreneur already comes with a lot of default context-free constraints, like, for example, vision, bias, intention, skills, specialization, interest, likes, dislikes, preferred models, methods, etc. The context-sensitive constraints, on the other hand, is dependent on the context that manifest only in the real-world entrepreneurial context. Once the context comes into being, then all of these context-sensitive constraints also comes into being. Like, for example, team members, partners, mentors, end user preferences, technology penetrations, government policy, infrastructure, etc. All these things comes together coherently in a self-organizing process, integrating all these context-sensitive and context-free constraints into a single system. According to Alicia Horero, these context-sensitive constraints synchronize and correlate previously independent parts into a systemic whole. So that's the role of context-sensitive constraints. Parts become correlated as a function of context-dependent constraints imposed on them by the newly organized system in which they are now embedded. Now think about this. If the entrepreneur already comes with rigid context-free constraints, default rigid context-free constraints like business plan or lean startup, then the self-organization process cannot happen. Okay, metastability cannot happen in this kind of systems. But if the default constraints are flexible, enabling in nature, as in the case of effectual self-organization, then it will facilitate self-organization and metastability. The default constraints needs to be accommodative and flexible. It is also important to understand that what I'm saying here is not to exclude lean startup and business planning, but do not put these prescriptive models as default constraints. Default constraints should always be flexible, extremely flexible enough to accommodate things, accommodate metastability, accommodate possibilities. If the possibilities are taken away, metastability cannot happen. That flexibility cannot happen. Now, I have introduced effectual self-organization as a primary keystone constraint to act like self-organizing systems. This was to reduce the autonomy hijacking potential and also to remind the entrepreneur that you are already a complex self-organizing system. That was a primary goal. But we can do much better than that, okay? So there are many, many self-organizing systems in the world, but most of these self-organizing systems will not live long. Because we are living in a social system, we can design solutions to extend the life of a self-organizing system. Our goal is to use context-sensitive and context-free constraints here to introduce various enabling constraints to increase the dispositional propensity of positive things happening in the system, that is the entrepreneurial system, and decrease the propensity of negative things happening. So by introducing various constraints, we can do this successfully. Now, before jumping into that direction, we also need to remind ourselves about some serious issues of concern when it comes to social complexity domains. Then, first of all, the nature of human social complexity is different from other complex systems. The adjacent possible in a domain like entrepreneurship is not locally or geographically bound. So adjacent possible is global in entrepreneurship because of the communication technology we have. According to Paul Sheldon and Dennis Felcher, who quotes Herbert Simon, the subsystems that constitute the complex system of the human body are spatially organized within the body as a physical entity. In contrast, the interaction of subsystems and subsystem components in social systems is unconstrained by spatial proximity because interaction is mediated by symbolic meaning systems. This unconstrained nature enables global adjacent possible. I can interact with people around the world in real time. So that is a possibility when it comes to social systems, because this is information system that is unconstrained by spatial proximity. Another key point is that adjacent possible in a complex self-organizing system involves unprestatable open-ended becoming. We cannot know what is going to happen also. Not only do we not know what will happen, we do not even know what can happen. So that makes it very difficult to understand also what is going to happen. The adjacent possible is global. So there's infinite number of possibilities there. It is not like a football game when it comes to entrepreneurship. In the football game, we can predict a lot of things because of the structured nature of the system. The second key issue is bounded rationality. Research has shown that bounded rationality challenges new ventures. Entrepreneurs often systematically satisfies prematurely across many decisions. As I already discussed, the process of satisficing is very important. It is extremely common. It is ubiquitous when it comes to human systems. But it is important to understand that this sometimes can have negative effect also. As a continuation, it is also important to understand that entrepreneurs may be driven by attractors of the local optima than global optima. And they'll be stuck in the local optima for many years before realizing the existence of an adjacent global optima. That is a key issue when it comes to a domain like entrepreneurship. It might also be very serious because other people also might conform with your own bounded rationality. Maybe because of groupthink and social pressures, this might happen much commonly in real world entrepreneurial situations. A key adjacent idea is that environmental constraints, including lack of exposure to relevant ideas or models, may prevent the travel to global optima. According to innovation historian Anton House, absent any exposure to inventors, people simply do not become inventors. Knowing about invention as an activity is a necessary precondition to becoming an inventor yourself. The vast majority of people never innovate for the very simple reason that it will never occur to them to do so. So this points to the importance of proximity and also affordances that is present in a particular situation. Anton House did a lot of historical studies to come to this kind of conclusion. Finally, it is also very important to understand is that your autonomy is always under threat. People are pushing their ideas on you at all levels, from local to the global. So this is a very important point and keep in mind when it comes to a domain like entrepreneurship. It is also important to note that it is not possible to confirm to the fact that people always have a good motive when it comes to helping us, or maybe it is possible that they are trying to push their things, something which is valuable for them on us. It is always possible. Now we know that these are all very serious issues we need to solve. But what is the solution? The solution is designing and introducing various default functional enabling constraints. I'll be using Alicia Herrero's framework, which includes context-sensitive and context-free constraints, to introduce these constraints. And this implementation will be discussed in the second part of this video. See you soon in the second part.